Thank you for joining today's session, Reviving into the Machine Learning Observability, a Data Generalist's Take. Welcome our amazing speaker, Anastasia Kulakova. Anastasia is an Amsterdam-based data science generalist with a master's in industrial and applied mathematics and nearly 5 years of experience. At Jetlix, she applies machine learning and advanced analytics to enable smart charging for thousands of electric cars. In her work, she prioritizes productionizing models, aiming to continuously improve and automate decision making. Additionally, as a Data for Good volunteer at Coral Aid Netherlands, she plays a crucial role in unlocking the power of data science for nonprofit organizations, making a positive impact through her expertise. Thank you, Anastasia, for being here today. I will now pass the session over to you.
Thanks for the introductions. Welcome to the session. Thank you for joining. And I'm super excited to speak today at Women Who Code Dev Summit. So before I jump into ML observability, I'd like to take a step back and give you a little bit of background about my career path and explain why I use the term data generalist and why I see the topic of ML observability through this lens. So I started my professional journey with getting a bachelor's in applied mathematics, and then I narrowed it down to master's in data science. So during this period of education, I did a couple of internships, and then I entered something that I call learning by doing period, because I know that some people, after they finish their masters, they start either specializing in one domain, getting PhD in this domain, or specialize also in the industry. But for me, it was actually many things that I tried in the data domain. So I was a machine learning engineer, BI analyst. Now I'm a data scientist at Jetlix and also a Data for Good volunteer at Coral Aid Netherlands. And actually, during my career, I never felt that the job title was ever like inclusive enough to actually describe what I do. Because, for example, as a machine learning engineer at the first company where I worked, I was more focused on the proof of concept project. And now, as a data scientist at Jetlix, I'm involved in the whole machine learning product lifecycle. So that's why when I heard the term data generalist, it really resonated with me. So I decided to call myself one. And as later I figured out, it's very actually beneficial to be one because with a data generalist mindset, you're able to build something maintainable that people also with wide range of expertises and not one single specialty can maintain on their own. And I already mentioned Jetlix. That's a energy and e-mobility startup where I work now. And what we do, we like to say we drive renewables forward, but to be more specific, what we do is we monetize the charging flexibility of electric vehicles, which makes it beneficial for the end user because we reduce the cost of ownership of electric vehicle by allowing them to charge in the most cheapest moments. And that is also beneficial for various players in the energy markets because we monetize this flexibility on the energy markets. So to be good at what we do, actually, we use machine learning extensively at Jetlix, and we have three main use cases. So the first one is capacity forecast. By capacity, I mean like the total aggregated capacity of the electric vehicles that end up in our fleets or pools of electric vehicles, and we need to know this way in advance. That's why we need forecasts. And in order to monetize something efficiently, you need to be aware of the prices also way ahead in time. That's why we deployed multiple energy price forecasts. And finally, if we zoom into particular charging sessions, we need to get the charge power estimations in time in order to know how fast the vehicle can charge. And actually now we also work with discharging. And for this, you need to know the charge power estimations. And that might seem quite obvious because the manufacturer of the car would normally put it in the description, but it's not that easy. And to give you a bit more details about the charge power estimations, I will add the link also to the blog post that I wrote for Jetlix, and you can check it out later. And as you can see, we have machine learning models running in production, and that is why machine learning models that run in production, they need some some treatment. They need to be reliable, and we need to take responsibility for this. And actually, if you look into the classical machine learning model lifecycle, you will see this. And as you can see, it's not like a journey with an end destination, but more of an iterative process with errors going back and forth, for example, from deploying model in production to training the model, from training the model to collecting data again. So iteration. And actually, ML observability is something that enables those feedback loops and iteration. So observability comes from the ability to observe, and ability to observe actually allows you to make decisions, make changes, and so on. So for example, for me, ML observability is this. For example, when you deploy the model, but then you see it's not performing on par with what you expected, so you go back and retrain it. It's about collecting the data again because your current data is not fresh enough. It's about collecting the data for a new model. All of this, for me, is ML observability. All right, so now that we know that ML observability is important if you want to treat your models responsibly, the question is, which signals can you look at? Because there are, of course, many signals that you can look at. And I normally like to imagine this whole thing as an iceberg with a part that is over the water, very visible, and so to say, the tip of the iceberg, right? And something that is under the water, but still is very important and could be actually the root cause of the issue that you have at hand. So if we go top to bottom, what do we see? First go the business metrics, something that describe how's the business doing. This is normally something related to revenue, your user growth, so whatever your business case is. And these are the metrics that are normally very well known to the business and also like to the whole, to many teams in your company. But this also is rarely the issue of its own. So if you see the decline in certain metric or some abnormal behavior, it's not like it's going to happen on its own. So that's why you need to go deeper into this iceberg to see what really happened. So what goes next is the system metrics. So these metrics describe the health of the applications that drive your business decisions. So I'm not jumping to machine learning related metrics straight away, because what's the point in having this fancy machine learning model there if the application that is using it is down? So that's why we need to look at system metrics first. So I already mentioned machine learning related metrics, and these are model performance and proxy metrics. So I ordered them in this succession because basically sometimes it's very hard to actually see your true model performance because your actuals, for example, they can be delayed. They will be available. Later. Let's say if you're predicting the sales of a certain item and the sales are going to be like this, the final figures are available by the end of the quarter, but you actually need some target to train on. You go and use, for example, click-through rates of the ad, this kind of stuff. So these are the proxy metrics, and the model performance is the basically, in this example, the sales. But again, models, they do not degrade on their own. So the root cause can be a bit deeper. And normally what we as machine learning people turn to is the data quality. So data quality, it is something that tells you whether the data you're using is still good. This is about freshness, that's about completeness, and many, many other things. There's also distribution drift that is often included in the data quality section. But for me, that's also a little bit different because it's not only about the data that comes in, but the whole data surrounding your data science use case. So the short answer, what distribution drift is the question, does my data still resemble what it was before? Because, for example, if you build your model predicting certain prices and then the volatility of those prices change, so there could be so that even the use case for your model is not there anymore. So that's why it's the broader term for me than data quality. And in this presentation, I'm going to focus on these four, the middle four. I'm not going to talk about the business metrics because I do hope that your business analyst already figured this out. And this is something that, is the first thing you're going to look at when you talk about metrics. And distribution drift, to be honest, this is also something very custom, and we haven't figured automating this kind of health check on our own at Jetlix. So that's why I'm going to focus on this 4 parts. All right, so here I would normally compare building versus buying, this huge trade-off when you decide how to actually approach the problem at hand when you need something in your tech stack. I'm not sure I'll have enough time for this, but if you're curious about this trade-off, yeah, please feel free to ask the question in the Q&A section, and I'll fast forward to what we decided to do at Jetlix. We decided to build our ML observability setup. And here's what we built. And in this couple of slides, I'm going to go over our setup. I'm going to break it into subparts and comment on the reasoning behind choosing these particular things. All right, let's start with the start. At Jetlix, most of our models are deployed as APIs. And this actually offers a lot of flexibility to our partners, or actually like our internal applications that call our models, because they can tweak multiple parameters. They can call the models whenever they want, and they will receive the fresh reply. However, sometimes it's actually the number of requests we get. This is not enough for us to draw valuable performance metrics and various statistics about our models. So that's why the first thing we decided to do is actually to make sure that the models are called often enough. And for this, we used schedulers. So schedule jobs that will call the API on the schedule. And you can use multiple things in here. We decided to go with Dagster. That's a Python library. And what's nice about Dagster is that it offers you this flexibility of having your DAGs not in one centralized location, but in different repositories. So if you break one thing in one repository, it's not breaking the whole application, so which is nice. All right, moving on. So we have something like a model deployed. We have the API around it. So what is it now? For me, it's a software. And what software people do when they have a piece of software, they try to track the system metrics. And we decided not to deviate from the industry standards. So our APIs, the right metrics to Prometheus. So these are the system metrics. And we visualize them later in Grafana. But what we also covered is data quality, because what is nice about Prometheus, it allows you to actually create your own metrics. So like in this case, we created a metric which we call no data. So this is a metric that will increment itself when one of the important features for a particular model is not available, so when it is none. And so we can then later plot it and receive an alert if we have too many of those cases. All right, so we covered system metrics already. Now let's get to the interesting part, performance tracking, and also the proxy metrics. And for this, actually, the first question that you need to ask yourself is, where are you writing your prediction? Because essentially, performance metrics are about the ability to compare your predictions and the actual data. So in our search for a nice analytics database, we found ClickHouse. It is blazing fast, it's easy to use, very well documented, and also it offers a lot of like custom functions. So we decided to go with this. But we also faced a problem that as an analytics database, it's not really tailored for this one-off writes. I mean, you could do that, but it's not really efficient. So that's why we did a bit of a workaround. So yeah, you remember our model API, and we decided to utilize request response logging. So we do this through Envoy. And also we write, instead of 1,000 writes of just one raw, we implemented batching with Vector. And so that one write of 1,000 rows will end up in our ClickHouse row database. And from there, we can pre-process the data, clean it, compute various performance and proxy metrics, and use it in our dashboarding tools and power the insights. So I already spoke about visualization. Our visualization tool of choice is Grafana. And alerting we do also through Grafana and the notification we receive at Slack. And so the setup is pretty simple. Grafana connects to Prometheus and to ClickHouse, and we set up different thresholds, alerting thresholds, and we're notified on Slack. So here's how it looks like. For example, here you can see the response time of one of our APIs. So you can see that there are certain spikes, but it's not actually meeting the threshold, the alerting threshold. So you see this nice green heart over here. You can also do this with your performance metrics, like mean absolute error. And you can also set alerts on this too. But as you can imagine, that's a lot of dashboarding and plotting to be done. But nice thing about Grafana is that you can template a lot of things. You can reuse them. Nice thing to Google actually is variables. You can set variables like endpoints, environment, country code in my case, and later reuse the dashboards with queries that you already built and reuse them. Okay, so I'm coming to the end of my presentation. Let me reiterate over the setup we've built. So we have the model API, and on schedule, it is being called. It can be also called by some external services, right? And every time that this happens, it writes performance metrics to Prometheus. So by this, we cover system metrics. What we also do, we do request response logging through Vector to ClickHouse. And by having our actuals and predictions in ClickHouse, we can then calculate various proxy metrics and some performance metrics. What we also do through Prometheus is data quality metrics. So as I said, we can do custom metrics. And we visualize it in Grafana. And if something goes off, we trigger the alerts that go to Slack. So yeah, for some of you that can look like a very simple setup, for some of you that can actually look like something that requires more work, but that definitely was an insightful journey for us to build this. So I'm gonna wrap up with 3 main takeaways that we derived for ourselves in this observability journey. So first one is embracing a generalist mindset. So this is about actually building something that can be maintained by a group of people with diverse skills instead of requiring a very narrowed specialist for each of the components. So this way you build something that is easier to maintain. Using 80-20 rule, so 80% of the result with 20% of the effort. It's actually true that the first 80% is very durable to achieve, but you need to select carefully on which things you spend this. So it's best to reiterate later and start simple. And finally, ask around. Yeah, solutions architects, friendly community, they're there to help you to actually integrate their tools into your stack. So here I'd like to thank ClickHouse community and also Dagster community. They were super responsive to our requests and helped us a lot. So yeah, with this, I'm going to close off. Thank you for your attention. If you're curious to learn more about what I do as a data generalist or what Jetlix does, feel free to scan the QR code. It's it leads to my website. And if you have questions now, feel free to ask. Thanks.
Thank you, Anastasia, for presenting on reviving onto machine learning observability. This was an amazing talk, and we all learned so much. While everyone is like sharing their questions, Anastasia, would you like to share what is the future of machine learning in general? Where do you see this going?
For me, there's no one size fits all approach, but I do believe that there should be more use cases, and the use cases will become more mature. So yeah, that's the future, wider adoption, so to say. I'm not going to talk about specific technology because, yeah, as I said, I'm a generalist, but wider adoption is definitely what we're going to see.
Right, amazing that you talk about being a generalist. So for someone who's like a young professional looking to be a generalist again in the space, but still want to have a good view of machine learning in general, would you what would you recommend as to where to start from?
Definitely learn by doing. Of course, courses, this is all nice, but yeah, don't hesitate to actually start with a job or internship. If you go for courses, pick the ones that enable you to do a project for the course. And actually, another opportunity that I would recommend highly, join as a volunteer. So I volunteer at Correlate Netherlands. That's a data for good organization. And what we do pro bono data consultancy for nonprofit organizations. And we're on the lookout for enthusiastic people. And we're also open to newcomers in data roles. So yeah, check us out. We also have chapters in other countries other than Netherlands.
We have a question from Samita. She's asking if we have a good learning resource to start with machine learning.
Yeah, not something on top of my head, but I enjoyed the courses from Udacity, and I'm currently doing one course on a specific package, and I think that they're quite good actually. Yeah, what else? Learn by doing.
Yeah, I think that's our amazing agenda for today, learn by doing. Yeah. All right. Thank you. Thank you everyone for joining in. Thank you, Anastasia, again.
Yeah, thank you. Thank you.